We're going to go ahead and combine together some logarithmic functions that are added or subtracted into a single logarithm. I'm going to go through 3 examples kind of quickly here, and we'll talk through each step. So the first one here, it's good to note that each one of these logs has the exact same base. These are common logs, so they're all log base 10. So to combine them together shouldn't be that difficult. First thing we're going to do is any of these multiples that are out in front, let's go ahead and move those up into the exponent. All right, so we'll start by rewriting this as log of 5 plus log of x to the 0.5 minus log of 7x minus 1 plus log of x minus 1 to the third power. All right, so take care of any of those multiples out in front first by moving them up, making them exponents attached to everything that's on the inside of that particular logarithm. Next, what we can start doing is we can start combining these together. On this first one, I'm going to take my time, not get in a rush. These two can combine together because they're added. They're going to be multiplied inside of a single logarithm. This is the more time-consuming way to go about this, and I'll show you the shortcut in just a second where we kind of bring along each of the additional pieces. All right, next we can go ahead and combine these two logs together, kind of working our way left to right. They become a single logarithm. This time they're subtracted though, so what's going to end up is the positive first log, what's on the inside there, goes into the numerator. And then the negative out in front of that second one says that part goes into the denominator. Again, carrying along the rest of this problem, that log of x minus 1 quantity raised to the third power. Finally, we can go ahead and combine these into a single log. Because they're both positive, they'll be multiplied. But what ends up happening is that means that the x minus 1 quantity raised to the third power ends up in the numerator with the 5x to the 0.5 power multiplied by x minus 1 to the third power. This is all going to be over that 7x minus 1. And we're done. But what I want us to note on this, that'll speed this up as you're working on these, if a log is positive out in front, like our log of 5 was, the 5 ends up in the numerator. After you take care of moving the number from in front, the coefficient, up into the exponent, the x to the 0.5 had a positive out in front, notice it ends up in the numerator. The negative log of 7x minus 1, there's a negative out in front, that ends up in the denominator. And finally, positive here, that x minus 1 to the third power ends up in the numerator, being multiplied by the rest of the numerator. So let's think about that as we work this next one. We're still going to work the same starting part, right? We have some numbers that are out in front, or 1 over x also happens to be up in front. Let's first start out by moving those up into the exponent. So we can rewrite this as log of x to the second power minus log of x plus 5 all raised to the fourth power. And note that 4 doesn't go to the x and the 5. It goes and gets attached to everything on the inside of that logarithm. So think of that x minus 5 was in parentheses raised to the first power. Now the 4 goes up into that exponent. Okay, and then where are we? Have plus log of, again, 3x plus 5. Everything on the inside there now gets an exponent of 1 over x. All right, a little bit complicated with that 1 over x, but don't let this throw you off. If we want to do this all as just one step instead of 2 separate steps, remember what we can do is we can say, well, this is going to be a log, same base 10 common log here. And let's think about what goes in the numerator, what goes in the denominator. Well, the first part is positive, so that x to the second power is going to go in the numerator. We end up with a negative in front of that second log, so that part's going to go in the denominator, x plus 5 to the fourth power. And then lastly, we have a positive out in front of this last log, that's going to end up in the numerator being multiplied as well. So it's multiplied by 3x plus 5 to the 1 over x power. And we've done it. We've accomplished our goal of combining it all together into a single logarithm with a coefficient of 1 out in front. All right, one more of these. Let's think about how would you want to attack this? Well, I note that we have some additions, we got subtraction, we got a 4 kind of hanging out in front. My first thing that I would probably do in this case is go ahead and say, well, it's just a number out in front here. Let's go ahead and distribute that to each one of these things that's added or subtracted. So take 4 times 3 log of x. Well, it's going to be 4 times 3 is going to make a 12 out in front times log of x. All right, but that 4 also needs to be multiplied by each of these other logs as well. So it's going to be plus 4 times log of x plus 5. And then 4 multiplied by that last one is going to go 4 out in front times log of 2x plus 3. Okay, so an extra little step there at the beginning to distribute the 4. The next thing is we have numbers out in front. We want those to be ones out in front, so let's go ahead and move these coefficients up into the exponents. Just attach them to everything that's on the inside there. So very similar to our previous example, we get log of x to the 12th power plus, we want that 4 to move up, so it's going to be log of x plus 5. Everything on the inside is now going to be raised to the 4th power here as well, minus log, and then 2x plus 3 is going to get raised to the 4th power. All right, now what I would do is go ahead and combine these into that single log to finish this up, and just say to myself, all right, positive out in front, x to the 12th goes in the numerator. Positive out in front, x plus 5 to the 4th power goes in the numerator. Negative out in front, 2x plus 3 to the 4th power goes in the denominator, and we're done. All right, make sure these are multiplied right in the numerator, not added or subtracted along the way. Hope this helps out as you're working on learning how to condense logarithmic functions that are added or subtracted into a single logarithm. Good luck.